We're back to the Saba Freiburg W2 Restoration, and since the last video I've done a little bit of cosmetic work, and which I will describe in a minute, but also I've actually found the source of that rather annoying hum that we were getting on the speakers, and also the high frequency or relatively high frequency oscillation, the 27 kilohertz that we saw across the speaker, and which I couldn't seem to sort out. What we have here to start is a little bit of the cosmetics. The knobs have been cleaned and replaced, the faceplate as well, and the most noticeable of all, the piano keys, which were in pretty abysmal state. As you can see, they clean up pretty well. I'll probably try and get the lettering that's very dim at the moment to stand out a bit later, but for now I'll leave it like this. It's always more pleasant to look at the radio as you're going along and seeing a radio rather than just an empty chassis. Also, it does help when you're trying to tune something, so you know more or less where you are. So, cosmetics aside, my main problem was an oscillation that was visible on the speaker terminals using the scope. And when I put the scope on, it's because I heard a hum, which could have been 50 hertz or 100 hertz. I wasn't sure, but it was somewhere there. And I had 18 volts or 17 volts peak to peak across the speaker at 20, I believe it's 27, 28 megahertz, which was pretty high. You can't hear that unless you're a dog, but since dogs don't seem to sign up to YouTube, I don't think that'll be possible. You can't hear it, but it is very noticeable, and the result was actually an audible hum as well. That one you definitely could hear. And what tended to happen is that the hum would go away, or the oscillation would go away, when I turned the volume up. When I put the volume at 0, this terrible oscillation was more than visible. And I went through hell to get to the source of it. But I'm happy to say that I found it. And I'll go through the procedure that I took and show you exactly how that problem was narrowed down and finally identified. As you can see today, it's maybe it's temperature related. It's gone up to 30 kilohertz. And it is 17 volts peak to peak. That is pretty high. It's a very high voltage, in fact. So what we have here is 5.8 volts RMS. That's what I am getting coming out of the speaker terminals with the volume completely at 0. So the challenge now is, or was, to try and figure out how this oscillation, which is obviously what it is, reflects on a audible hum coming out of the speaker. Obviously I can't hear 29 kilohertz, but it's coming out of the speaker. There's a hum coming out of the speaker, and the hum is very, very audible. Now, I'm obviously not hearing the 29 kilohertz. As I said, I can't hear anywhere near that high. I'd be lucky at my age to get halfway, but that hum is audible. And I wanted to know whether that was 50 hertz, which is the mains hum. 50 hertz would indicate that I have a problem with the heater supply leaking through to the tubes, or whether it was 100 hertz, which would indicate a filtering problem, because that is the frequency of the ripple that I get after the Selenium rectifiers rectified the AC. My problem was, with an oscilloscope across the speaker, I can't read that hum, because this voltage is so high that when I try and at 29 kilohertz, when I try and get the oscilloscope down to where 50 or 100 Hertz would be visible, that's all I see. Obviously there's a ripple at the top, and I presume that would be the hum that I'm hearing, but I needed to get a bit more accurate. So I thought about filtering this and filtering away the higher frequencies. I tried that on the scope, put a low pass filter on it, but the lower end of my low pass filter in the scope is 50 kilohertz, so that gets through pretty well. So I couldn't isolate it. And then I remembered that I have a little app that does the trick. Using this app on my iPad, it's the frequency wavelength function generator pitch detector function of EE Toolkit's app. I have a pitch detector, so when I put the microphone close to the speaker, I get 99.1 Hertz. Now that seems to be pretty close to what I'm getting here. If you see the little bumps, if you take that as a sine wave between the two cursors, obviously it's moving and it's difficult to read. It would seem to be in the 100 Hertz range. So I'm getting 100 Hertz hum coming out of this with absolutely no signal going into or coming from the volume control, because I've got the volume control at 0. Now I'd measured earlier and the ripple on the filter capacitors was actually very, very low. So I started doing a lot of testing and a lot of checking and came up with something which I want to show you. Playing around inside a tube radio that's switched on requires a little bit of care. There we go. It's gone. The ripple is gone. Let me show you that in another way. There it is. And gone. So I've detected the source, and it would just be too easy to show you what I've done. I'll go on to the schematic and give you a bit of a rundown as to how this conclusion was arrived at. Here we have a clean schematic. I'm focusing obviously on the amplifier and preamp stage, because obviously that's where I would check first, and that's exactly how I went about it. What I did was I checked. I'm getting hum out of here, 100 Hertz hum coming out of here, and 29 kilohertz of ripple or oscillation coming out of this point here. If it's at this point, it would have to be on the primary of the transformer as well. Lo and behold, it's there and it's there, with one major dramatic consequence, and that is that if you recognize what this transformer is doing, it's got a primary oscillating value over here that's reflected on the secondary side. I'm reading 17 volts peak to peak over here, and over here I'm getting full rail supply practically, 300 volts peak to peak or more. So what is happening here is this oscillation is creating such a drag on the power supply. So the oscillation in here is dragging this power supply line down and forcing it to let the ripple through. It's increasing at 29 kilohertz the current draw through these two tubes, and the current draw gets rather excessive to the point where it is dragging the supply voltage down, and when the supply voltage is dropped it shows any ripple that's on it a lot more dramatically, and that is what is showing through on here. It's showing that 100 Hertz that comes out or comes through the filter capacitor, and it's showing it in rather dramatic form. So I'm basically getting the entire ripple. It's almost as if the capacitor is having no effect, although obviously it's there and it's working. So rather high oscillation values here. Next step, test the input of the tubes. And I tested that pin there, the grid, and that pin there. And both of them have the oscillating voltage coming through. So it is not in the two output tubes, which is a relief because EL41s are rather difficult and expensive to come by. So I had to move back. And the next stage would be these two that feed the output stage. I checked the anode of this EABC80 and the ripple is there. I checked the anode of this EF40 and the ripple is there. So the next thing is to check the inputs. And the input, the easiest input to check would be the wiper of the potentiometer, the volume pot. And that is pin 5 of the EF40 and the ripple is there, or rather the oscillation is there. So this comes to, one comes to the conclusion this is prior to these two tubes. Now what is prior to these two tubes? We have this potentiometer here is fed with the audio signal through this cap here. And I needed to check whether the oscillation was coming to the radio from the back-end circuit or from the audio circuit. So I disconnected this cap, measured that point over there, which is where the signal joins to come into the volume pot. There I had no ripple. I checked that side and that's where the ripple was. So if the ripple is there and not there, it means that all this is fine as far as this oscillation is concerned. So the oscillation obviously comes from here and it's coming in at that point. So I disconnected that point, pin 5, and I checked the valve because it could be something crazy coming through feedback inside the valve circuit. There was no oscillation there. I checked the wiper of this pot and the oscillation was there. So this pot is fed with a signal which has no oscillation, and it's also fed with a feedback circuit. Part of the feedback is from the speaker terminal through this 1K6 resistor. It goes back here, it goes to the ground connector of the volume pot. But it also goes through a second tapping here, through a filter network here. There's a 25 nanofarad capacitor in series with the 20K resistor. What this is doing is it's actually affecting the loudness of the sound at low volumes. So that's also coming in. That is coming in. And also this transformer here, which I was totally unaware of its function. This transformer has one winding that comes to the ground or the bottom end of that potentiometer, goes through there and goes to ground. So in terms of DC, this transformer or the bottom of that potentiometer is effectively at 0 volts, because this would have very, very low resistance. I measured it, it's 0.4 ohms. I beg your pardon, it's 4.6 ohms. So it's a fairly low resistor. So this feedback effect comes into this point, and also in here you have an induced signal from this coil, which is also part of the feedback loop coming from the anode of this tube. This section here is fed via this point by the B+. So we have B+ coming in here. There is a resistor here through one of those tone control switches, switch A. Then it goes to 300K back to a high voltage point here. This point gets its supply, its B+, through that winding of the transformer, of the output transformer. So there is a high voltage here. This is a hot point. No DC voltage goes through that leg, although AC does, because there's that switch which is also part of the tone control. There's another one here, and then you have this coil. So I figured it must be something to do with this transformer, this feedback circuit. So what I did was I disconnected this resistor, and the hum continued. I disconnected that resistor, and the hum continued. I disconnected the B plus from here, and the hum continued. So I then decided to check the windings of this transformer. And that's where the problem lay, or lies. This winding is fine. This winding is 4.6 ohms, it's fine. This winding is open. And the way I figured this died was, it's a very thin wire. It's very, very thin wire. I've been checking the net and it's about 1.2 kilo ohms. So there's a lot of windings going on in here. And it has B plus over here. It goes through there, and then you got all these connectors to the tone control switch. My guess is that somewhere here there was a short to ground. If there was a short to ground here, which means someone touched it and shorted it to the chassis, for example, which is grounded, that means B plus goes straight through there. And obviously this is not meant to be shorted to ground and to pass all that current through there. Probably not enough current to have killed the protection fuses, but certainly enough to fry that winding. So here comes the first problem. This feedback transformer, once I did some checking on the net, actually goes dead quite often. And it was used in quite a few of the radios. It was used in the W2, Freiburg W2. It was used in the W3, in the W1, which is just the W. It was also used in the Saba Freiburg series, models Freiburg W and Freiburg W1 and 2. And there are also a couple of others. The Constance also uses it and so on. So they are notoriously prone to failure and very difficult to get. What I had to do then is I've got to try, what I have to do then is try and find a replacement for this transformer. However, that could take a while. I've actually found a gentleman in Germany who winds these things, and I spoke to him today, and he's quite happy to go ahead and rewind that winding for me if I send him the casing, which is probably what I'm going to do. But I wanted to get this radio working and complete, and then just leave this to the end. So I had to find a way of cancelling that hum effect for now, and I figured the best way to do it was short that to ground. That point over there goes through here to ground. What happens is when this circuit acts as a feedback circuit, which it does, it takes signal from there, it feeds it back. It is tonally corrected. In other words, depending on which switch you have on, which position of tone control you have on, there is a tone correction that happens. And this part of the signal actually goes through here. And what happens then, so this point here is pulling current from that B plus line through the winding, and that induces the signal on the output transformer. What this is doing is it's inducing a similar signal here through there, through that 300K resistor. Obviously a much smaller signal, but it's doing exactly the same. So what we're getting is a portion, a tonally modified portion of the output signal is produced across this coil, and therefore is induced into that coil, and therefore that signal is added or subtracted to the volume control, to the volume pot. If I short this to ground, in terms of DC it's doing nothing. It has no effect. It's exactly the same. But in terms of AC, what it's basically doing is creating no feedback effect from this line. It is, however, going to leave me with part of this function operational, because through this B+, through those three branches here, I'm still getting some effect to the anode of that tube. And that's exactly what I found. When I took the signal away, or when I took that oscillation away for you on the oscilloscope a little while back, what I was doing is I had a crocodile clip stuck to there, and then I touched it to the chassis, which is ground. And I've noticed in prior experimentation that the tone control still works. Obviously not the entire feedback effect is in place, but it still works. And that's what I want to do. I want to get this radio working without that annoying hum and without the rather scary oscillation values, so that I can get this to the point where it is completed. And in the meantime, hopefully I'll find a replacement transformer for this, or I will send it to the gentleman to be rewound. One of the reasons that that hum or that oscillation was worrying me, it's not so much the 100 Hertz that was audible, it was actually the oscillation, because what we have there, we had about 5.8, call it 6 volts RMS across the speaker. The speaker is 4 ohms. Now, power is V squared over R. 6 squared over 4, 36 over 4, 9 watts. That oscillation represented 9 watts of power. Obviously, the speaker is not reacting to that oscillation, but in terms of heat, that voltage is going through there. Through that resistance, it's creating a current, and it's heating the coils of the speaker. So in all likelihood, if I left it in place, I'd probably be doing some pretty serious damage to those two speakers, to the speakers in the radio. But more importantly, I'm also doing quite a bit of damage to the output tubes, because they're also reacting to this. Those tubes can work very, very well at 29 kilohertz and way beyond. So those tubes are at 9 watts between them. And I'm not quite sure what the rating is for this EL41, but I have a faint memory that it is probably around 9 watts each. So basically, without a signal, I'm stressing those tubes quite dramatically and unnecessarily. So that problem is resolved, and we can move on to continuing with the restoration. So what I'm going to do is I'm going to solder this little wire in to the points that I pointed out. It's to this, where this 1.6K resistor goes in. And then connect it to a convenient ground point. Here's one here. I'm leaving this with a rather temporary look on purpose. And that is so that there is no doubt in the future when I come back to repair that A, that I ever forget about it, and B, that I have any problem identifying where the connections are. The radio has all the capacitors replaced. All those black Sabas have been replaced. There was one that was replaced with a silver mica over here. This was the one that comes in from the antenna. It's a 500 picofarads. That was rather grubby as well, so that was replaced too. All the capacitors have been replaced. The electrolytics have been replaced. And a fair amount of oiling, lubricating, cleaning has been done. Wherever there are the pivot points, put a drop of oil, not too much, just enough to ensure that it flows smoothly and we don't get any scratching. First of all, obviously cleaning it with contact cleaner before oiling. So that was all done. The same applies to these switches. These are the switches that are activated by the push buttons, the piano buttons on the front. All these were cleaned with contact cleaner. And I'm left with one challenge. and that is I have no shortwave. I have everything else working. The shortwave is not working at all. So there's obviously a problem here somewhere. I would imagine it's a connection, a switch that's not making contact, something to that effect. Something as simple as that. It is not a capacitor because, or at least not one of the main capacitors, because they've all been replaced. I was hoping it would come back in replacing the capacitors. That's not the case, but it's something to do next. Another thing you may notice here, all the piano keys were cleaned. They cleaned quite nicely. But what I wanted to show you is that these little things there, those are the little lights underneath the push buttons, the piano buttons, and they light up. And this is what they look like. They just screw on there. These little lamps burn out. A lot of them have burnt out. I think 3 of these are burnt out. And I need to check them individually and replace those that are burnt out. I have I know you can find these. They're 5.5mm threaded. But I've been replacing them with also 5.5mm, but it's a slightly different shape, and they seem to do a good job. The ones I'm replacing them with are actually 9-volt lamps. They're slightly dimmer, but they're good enough and they're easily available. Right, so I think that's it for now. And just a quick look at how this contraption that I've got makes it so much easier to work with. The radio can be flipped around, and you're not worried with damaging valves or transformers or connectors at the bottom. It really makes it a breeze. Okay, that's it for now. See you soon.